Hello everyone and welcome to Netmastery Zone channel. In this video I'm going to continue our configuration that we just started before for creating this lab. If you remember that we designed this lab in the EventG, and after that we just start our configuration in this. Let me explain briefly about what we did in this lab before in the couple last videos. First, we just configure our layer 2 configuration in the data center. Here we configure the spanning tree, also the trunking protocol between these three switches, and also some ether channel between the switch 4 and switch 5. And after that we just configure the active standby between these two switches using VLAN 10 and VLAN 20. And after that we just configure the OSPF in this data center, and also did some configuration in traffic engineering using cost in OSPF, and also OSPF authentication. And after that we just configure the EIGRP in site 1, site 2 and site 3. In site 1 we use the EIGRP classic mode, site 2 EIGRP named mode with authentication. Also in site 1 we add authentication here, and in site 3 we use the hybrid of classic mode and named mode EIGRP with authentication. And in this video I'm going to configure the OSPF and MPLS inside the core network. Actually this core network is going to provided by the service provider. You just need to rent a link of MPLS and then connect your network, different sites of your network to that. But we actually need to know how this configuration will be done inside the service provider network. You can see this two router here. The router that is the router that is connected between the client and also provider. This router is called as a customer edge, and this one is called the provider edge. You can see that we have two customer edge router here in data center and one in every site, and also there is one for every site, the provider edge. You can see that we have VRF here, and I can explain, I will explain this why we have this VRF actually inside our inside the provider network. We are going to configure the MPLS here, and why we are going to why we need actually the MPLS. There is many reasons that we need to configure the MPLS here. Today actually MPLS is going to be replaced by the SD-WAN, but in my opinion it will take a long time to replace all this network with the SD-WAN, and also sometimes there is no reason to switch it to SD-WAN because the MPLS actually is doing its job very well. We don't have any problem with the MPLS. And the reason that we are using the MPLS is, the first one, we can say that the scalability. Actually we can connect our sites in any place that we want. Just connect that to the MPLS, and we can access our sites in all world. And then we can do traffic engineering with the MPLS to select one path instead of another path. Also it's supporting the quality of service QoS, and we can say the isolation and security. As I said that we are using the VRF here, isolation and security is very important for our network. We need to isolate our routing table, and that routing table should never be shared to other customers that may be connected to this MPLS. We can say that there may be a lot of other clients that already using this MPLS here. Client no, the customer that using this MPLS network, and every customer that has its own routing table, and these routes will never leaked from that routing table and go to others customers routing table. And this is very important for the security. And also it's supporting the multicast. Actually, if we have a multicast site, for example between site 1 and site 3, if we configure the multicast, we can easily do that because the MPLS supporting the multicast also. And also the good thing about this, that if we use the MPLS here, this MPLS is going to be managed by the provider, and we don't need any extra configuration or any extra job here to manage our MPLS. But now we are going to learn that we have to do that. But in the real world, if you just rent a MPLS link, the provider will just provide you some information about the link, IP address and so on, and then you can easily connect your site. You don't need to be concerned about this configuration inside the MPLS. But here I'm going to configure the MPLS, and we can see that how we can configure this MPLS, and also OSPF here, and we can use some configuration of OSPF to enable the MPLS between these 7 routers here. And the first thing that about the MPLS that it's important to know, that the MPLS need actually router ID, and this neighborship will be made between these 2 different router ID. For example, if I want to enable the MPLS between R1 and R2, I need to select the router ID between these 2, and that router ID should be its IP address, and that IP address should be available for example for R2. If I use the loopback IP address here, that loopback IP address should be inside the routing protocol, for example in the OSPF or EIGRP, to R2, that be able to ping that IP address to create actually a neighborship with R1. For that, let's I'm not going to speak about the details about the MPLS here. You can find these details if needed in many websites inside the internet, in the Cisco documentation also. But let's just my main goal of this videos is here to practice, not to speak about the details here. And for that, let's start from R1 and try to configure the MPLS and also OSPF here. I'm going to do both of them in the same time because they are also have a relation to each other, and to both of them I mean the MPLS and OSPF because they already have some relation to each other. For that, let's go to router 1, and first let's select the protocol of MPLS that we are going to use. MPLS label protocol LDP. I'm going to use LDP here, and let's configure a router ID for that. MPLS router ID. MPLS LDP router ID loopback 0, and we have a option here force. It means that if there is any other interfaces used as a loopback ID, with the force command we just change that to this loopback interface without restart or anything else. Okay, now the MPLS just very easy. We just use 2 commands. First select the protocol, and then we just select the router ID for that. Now let's go to the OSPF and configure the OSPF here, and also enable this MPLS inside the OSPF. For that, let's go to router OSPF1 and then select the router ID for that. If you saw the last video, that you know we just have a router ID of 10.10.10.1, and it's different for R1, R2, R3 as a router ID. It's very important to have this loopback interface here. It's actually the loopback address. Let me show you. You should run interface loopback 0. This is a full mask of a loopback 0, because we need that because for our BGP and also for our MPLS here. Why I'm going to use the loopback for the router ID for MPLS? Let's assume that we have another link here, and if I just use, for example, this physical interface E00 as a router ID, and if this interface is get down, then the other link also will be down, because this route will not be available for R2, and R2 just making this neighborship to router ID here. If it's not be available, then this LTP and also BGP will be get down here, and because of that we are using the loopback interfaces, because loopback interface is a virtual interface. You never get down and it's always available. And we just assign the router ID for OSPF, and here MPLS LTP autoconfig. Why we are using this command? Because I'm going to enable the MPLS, the OSPF actually inside the interface, not as a network command. The benefit of that is actually it's very easy, because we just know which interfaces, for example in R1, which interfaces is going to be connected to the OSPF. In this router one is all interfaces actually is connected to another router, and it's in the OSPF domain. But for example, for if we think about this router R6, only E00 and 01 is connected to OSPF, not E02. And if we select a network, then I need to write a specific network IP address of this in the OSPF, and it takes long time, and also during the troubleshooting it makes everything very complex. And if it's a range of network, also maybe this one is also being the range of the OSPF, and in the range of the same IP address on this too, and will be enabled the OSPF in this link, and we don't want to have a OSPF here. Okay, now the auto configuration is enabled here, and let's enable the OSPF inside this interfaces. I'm going to use the interface range here, E00 to 3 and E1 by 0, and most important loopback 0. As I said, the loopback 0 is very important because we use that as a router ID for MPLS, and if it's not be available inside the routing table of other routers, it will never make a MPLS neighborship between these two. Okay, IP OSPF1 area 0. Now this is run. Just let me check the interfaces if all of them is up. Do show IP interface brief. I will exclude unassign. Okay, you can see that all this interface is enabled here, and this one is shut down. Let me turn it on. No shut. It's overlapping with this one. Yes. Let's change that. Interface 01 IP address 172.18.1. Should be 5. Okay, interface is 0, no shutdown. Okay. Now let's go to R2 and do our configuration here also. MPLS label protocol LDP, MPLS LDP router ID loopback 0 force. Okay, router OSPF 1, router ID 10.10.10.2 and MPLS LDP autoconfig, and then interface range E00 021 and E1 by 0 and loopback 0 and IP OSPF 1 area 0. And you can see that in a moment these two routers should be neighbor together. R1, yes, the OSPF is run, and now we are waiting for the MPLS LDPS. The MPLS LDP is also up here, and let's go to R3 and do the same configuration here. MPLS label protocol LDP, MPLS LDP router ID loopback 0 force, and router OSPF 1 router ID is 10.10.10.3 and MPLS LDP autoconfig, then interface range loopback 0 and E00 IP OSPF 1 area 0. Okay, let's wait for that also if the configuration is correct. Yeah, the IP configuration is okay, and now the OSPF is run and the LDP should run in a moment. Yes, we have LDP also here. Let's do this configuration in all our routers here, and at the end we will check, we will do some command for MPLS to see the labeling and also see the actually the routing table, I can say. Conf t router OSPF 1. Let's do first MPLS label protocol LDP, MPLS LDP router ID loopback 0 force, router OSPF 1 router ID 10.10.10.4 and MPLS LDP autoconfig. Let's interface range loopback 0 E0 021 IP OSPF 1 area 0, and this is okay. And let me tell you something, that if we don't use this MPLS LDP autoconfig here in the OSPF, then we can use this other command here. Let me show you in the router 5 that which command that we can use here for the configuration. Conf t MPLS label protocol LDP, MPLS LDP router loopback 0 force, and router OSPF 1 router ID 10.10.10.5, and let's go to interface range loopback 0 E00 to 1 IP OSPF 1 area 0. Okay, now we didn't use the command of MPLS LDP autoconfig here in the OSPF. In this case, that we will see only, we will have the OSPF agencies here with R5, that now agencies with R1, and let's wait for R2 also. This one should also be run. Let me see if there is any problem in the interfaces or not. R2 sure on interface 03. Router 03 is not in the MPLS actually, yeah. We just use the range. This range is strong range here. It should be up to 3. IP OSPF 1 area 0. Okay, now we have a neighbor, OSPF neighbor between R5 and R2, but not MPLS neighborship, because we didn't run the command of MPLS LDP autoconfig in the OSPF. For that, let's do something. Let's go to interface range is 00 to 1, and then command MPLS IP. It's the same, and now the MPLS just turn on here in these two interfaces, and we can see that the neighborship is up. There is not much difference between these two, but enabling this in the OSPF, that makes our configuration easy and fast, because when we just go to the MPLS, we enable that command and then only enable the OSPF in these interfaces. Doesn't need for MPLS IP. And also for the troubleshooting, that one makes our job very easy. Okay, now let's go to R6 and do this configuration there. Conf MPLS label protocol LDP MPLS LDP router ID loop like 0 force, and then router OSPF1, router ID is 10.10.10.6, and MPLS LDP autoconfig, then interface range loop by 0 first, and then E00 to 01. IP OSPF1 area 0. Okay, now R6 should have two agencies with with R1 and R2, and then two MPLS. Yes, now two MPLS with R1 and R2. Let's go to R7 also. This is the last router. MPLS level protocol LDP, MPLS LDP router ID look like 0 force, and router OSPF1, router ID is 10.10.10.7, and then interface range look like 0 and E0 0. IP OSPF1 area 0. You may notice that we didn't run the MPLS LDP autoconfig here. Then let's go to interface E00 and MPLS IP. Before I'm pressing enter here, I'm waiting for the OSPF. You can see the OSPF is run parent, and after having this command, you can see that we have the LDP MPLS LDP neighborship also. Now our MPLS and also our OSPF is configured here, and now we can check in the R1. If you see that we have a neighborship between R2, R3, 4, 5, 6, and 7 will come, because this actually the loopback interface of this one is already shared. It's available in all the routing table of all other routers. For example, if I would go to R6, show IP route OSPF, and this is, you can see, and the routing table is this loopback interface is available in all of them, and we just use this loopback interface as a router ID, and then the MPLS will up with all these routers. Now we have some commands here that we can use for our actually to verification of the MPLS. For example, first one is show MPLS interface. You can see that this interface is for troubleshooting purpose. Actually, if we wants to know that in which interfaces that we have the MPLS, you can see that we have MPLS in this interfaces here. And if I check on router 3, you can see we only have one interfaces that has MPLS enabled. Show MPLS interface, and only this router, this interfaces, and because this interface is in the OSPF, and OSPF is just as a command of MPLS LDP auto configuration, and all interfaces that is added to the OSPF will be also MPLS will also be enabled on that. And the other command that we can use here, show MPLS, you can see here it was the MPLS interface that I used. Then we can see show MPLS IP binding, and you can see that the label that is already selected for this, and you can see input label and also output label for this. And also we have another command here, show MPLS show MPLS forwarding table, and you can see the different labels for the different IP address that is selected here, and also the pop we have MPLS using two I can see process for putting the label on that, push and pop. When it's going to send the route from one router to another router, it just push a label on that and send it, and when it receiving other router, it will pop that label and push another label to that to send it to the next router. And in this, because it's a MPLS, multi-protocol label switching, and it makes job very easy for the router actually, because it's just using the label for sending and receiving the routes, and it doesn't need to use a lot of process to find the route and to make a routing table and so on. And because of that, the MPLS is very I can say scalable and very light protocol to use for forwarding the routes, especially when we need to use that inside the inside the BGP actually, and the BGP VPN v4, because we have a VRF here, we have this different VRF here, and we need to enable the BGP VPN v4. I will going to show you how in the next video. In this case, we need a MPLS to actually forward our route here, and also in the next video I'm going to configure the R1 as a route reflector client for BGP, and R2 will not have any BGP routing. It's not going to be inside the BGP. Then we need to send our route from here to, for example, to site 1, and in this case the MPLS will help us to send our routes correctly to the destination that we want. For that, and because of that, we say that this is the very secure protocol and isolation and security of the MPLS protocol to enable the customer to manage their own, not actually the customer, to enable the provider edge to make different routing table and store every customer routes in its own routing table to for the security reason. Okay, our video is finished here. I think it was very short because the configuration of MPLS actually doesn't have much of detail, and it's not too long. Just enable the MPLS and also make a router ID for that, and then we already learned about the OSPF in the other videos here. Okay, thank you for watching, and please subscribe our channel, the Network Mastery Zone NMZ channel, to see different labs. Actually, I'm trying to make everything practical, not theoretical. You can find theory everywhere in the books in the internet, but practically it's very important to practice. And if you just read the books, it doesn't help you to become an engineer, to become a network engineer. If you want to learn, you need to practice and practice and practice. You can download this lab. It's already available in the comment of the videos. You can download this lab and then continue this steps that I'm recording video about that, and then make it on your own and just practice. Every time you practice, you make a mistake, and by making that mistake and troubleshooting that, you will learn a lot about that. Actually, the learning is about making mistake. If you make a mistake, you will learn, because you are going to check where you made that mistake, and when you find during this process to find the problem here, actually you will learn a lot about that mistake, and also many others things that it comes to troubleshoot that problem. Okay, thank you for watching, and hope I see you in the next video.